welcome to our YouTube channel, MedCourse, Master in Equilibrium Thermodynamics. Today, we will talk about a very important thermodynamic property. So join me in this video to learn more about Gibbs energy. Gibbs energy was a concept developed in the 1870s by Josiah Gibbs. He originally termed this energy as the available energy in a system. His paper published in 1873, called Graphical Methods in the Thermodynamics of Fluids, outlined how his equation could predict the behavior of a system when they are combined. Before defining Gibbs free energy, he applied the principles of thermodynamics to chemical processes and discovered the chemical potential, which makes reactions proceed. Although his contributions were not immediately recognized, he was awarded the Copley Medal of the British Royal Society in 1901, which was basically the Nobel Prize at the time. What comes to your mind when we say the word spontaneous? You might think about something that happens immediately or quickly. However, in thermodynamics, there is a very specific way to determine whether a process is spontaneous or not. A spontaneous process happens when a system has enough energy available for a change to happen naturally in it. Do not confuse it with an immediate process though. An example of a spontaneous process in nature is the conversion of carbon into diamonds. Even if it takes millions of years to happen, it is a spontaneous change. So today we will learn how to tell if a change will happen spontaneously or not. The concept that will allow us to do it is Gibbs free energy. Gibbs free energy can be calculated as Yet, this equation is valid as long as we have a closed system with one pure component in mechanical and thermal equilibrium and during an irreversible process. Notice how we can calculate the change in Gibbs free energy because we are comparing two states in a system. You might wonder how this equation relates to spontaneity. Well, if the change in Gibbs free energy is less than zero for a process at a constant temperature and pressure, the process will happen spontaneously. However, if the value of Gibbs free energy is greater than zero, we're talking about a non-spontaneous process, in which energy would need to be added to the system for the change to occur. Nevertheless, if Gibbs energy is equal to zero, the system is in equilibrium. In the real world, the concept of Gibbs energy can be applied to understand biological systems. By applying the concept of Gibbs energy, it is possible to explain why the proteins related to complex living organisms cannot remain stable when facing high surrounding temperatures. When temperatures vary below or above the equilibrium temperature for a certain protein, the system cannot maintain its equilibrium, causing that the protein denatures. We can understand this result in terms of Gibbs energy. When temperature remains at a given range, which is specific for every protein, Gibbs free energy is lower in its nadir state, meaning it will tend to stay that way. However, when it goes below or above this range, the protein will unfold and switch to its nadir state and lose its biological activity. We've seen so far that the Gibbs energy determines the spontaneity of a process. Spontaneity does not mean it occurs randomly or out of nowhere. In thermodynamics, it means something occurs under given conditions without energy inputs. When the result of calculating Gibbs energy is negative, the event is occurring spontaneously. When it is positive, it is a non-spontaneous process, and it would require additional energy. And last but not least, when Gibbs energy equals to zero, we can say that the system is in equilibrium. What we've learned so far, here is a series of questions related to today's review. You will have 10 seconds to answer each of the following sentences. Are you ready?